Okay, guys, I want to show you. I want to get into this for you. Take note of this crack here. I put it in a little. It's in a little highlighted box. So if you have an Apple product, you can go to markup, screenshot something, then you go to markup. You at this point in markup, there's a magnifier there. You can increase the magnifier like this. And if you got a PC, you find your magnifier. You can run the magnifier along, and now you get to investigate a little bit more profoundly. For example, we can correlate this box to the column now. With this magnifier, you can see, forgot to do my summation. Sorry. I'm just adding more data, showing you guys also how to find this data and share it with me and share it with other forums, perhaps. I say perhaps because I'm biased against the other forums because of obviously I am because of the track they've gone down. With that said, there is one guy over there, the one that I keep talking about. I think he's my DOS over there, except for DOS likes me. This guy doesn't. But he does a great job. DOS is like really, advanced in his learning skills. That guy JR over there or something like that. He's a mechanical engineer. He states he's doing a great job. He sometimes it's quite irritating to me that I'm getting ready to post something, and I'll just troll on over there. And this guy him and I must be connected somehow, because I'll see he'll post something just before I was ready to start the video. And I'm like, really? I'm like, wow. Even told that to my girl. I said, look at this guy. He's so he's nailed my video before I've done it. with something he did. He's off sometimes with his thing, but his content is what I was going to share. For example, I'm posting this now. I didn't go over there. He's probably already posted it like an hour ago. That is so funny. But I'm sharing this because maybe he'll learn how to use it also. We shouldn't fight each other on this topic. Sort of, we can fight over how it's ultimately ended, and it resulted. But we want the data. We shouldn't fight each other on sharing data, whatever the data may be. That's not the way we're going to resolve issues. So here's data. As you can see, this is part of the theoretical punch out in the bars. You can see that they're here. I don't know how to give you this image to share. I'll leave it here. You can screenshot my video and take it from there. But frankly, I don't know where I got it from anymore. So we're looking at the base of 12. 12 is pretty much intact. And you see just a little bit, so you can start putting this back together, back into the OSHA report. So let me jump to the OSHA report. Great. Let me talk about this, and I'll change pages on the OSHA report. We're looking at it now. This is what I showed in my previous videos, how if you were in my scaled product. First off, I got to do a correction. It appears that they might have post-tensioned the transverse cables 1, 2, 1, 2. In other words, west, east side, west, east, west, east, west, east. I do not know if they balanced that, meaning they did one and then went to the other end of the bridge and did it, and then came back to this end of the bridge and did it, and then back to that end of the bridge and did it. I do not know if they balanced it in that capacity, or did they just ripple the forces all the way out to one side. That's what I visualized. I visualize load paths differently when they're being stressed. And so I imagine like a rippling, a wave. You're pushing it down if you don't keep it in equilibrium. Just like tightening the nuts on the head of an engine. We all know that you just can't go from one side to the other side and expect you have equal torque everywhere. Equal clamping force. Same thing here, buddy. Same thing here. All right, so post-tensioning 11, I believe, put forces down 10. And this scaffolding being just on blocks and haphazardly, that's a wrong characterization. So it's just on blocks on top of dirt. When I said haphazardly, I meant without being on concrete. Possibly it was tamped earth. But of course, the time of this is the load paths would have to be established on the scaffolding. If this is 10 and the forces are going down 10, well, clearly the load paths are concentrated more on this one here. This is where I want to see some deviation to prove my point. Deviation in this a bar like this one. Or did the bar just slip? Need more photographs. It means it wouldn't show deviation. It would slide up. Over here is where we also need to see the shims to see if when this was load tested, did they leave it in place, some type of formwork, false works. This was as the drawing state was supposed to remain in place. All of this on this decking here until they made it over to transported it during transportation. That never happened. For clarity, and then I'm going back to the content I was at, is that when they post tension 11, they did not. They had only D1, the longitudinal cables D1 times 2, which is a minimum of I think roughly 547 kips, way below the 700 plus on the sistering D2 out to D6. My numbers might be off a bit. But they did not have the transverse cables post tension yet under this. So they clearly, whether it be Erica or the other guy I discovered, shared with you yesterday, rather, let the discovery go yesterday. I've been trying to nail him down. I could not. So it's between Erica, him, ultimately Denny Pate, and VSL all signing off on this. It's just a hodgepodge of engineers jumping in here. And none of them are seen to be talking to each other based on time restraints and money, etc. So it appears a $14 million or whatever they got reserved for this bridge structure, $10 million bucks, maybe $8 million. That's not enough for these engineers, or is it not enough for MCM to share with the engineers as a priority? So throwing MCM and taking a narrative effect, if you will, throwing MCM under the bus, they said they clearly are the ones going to profit the most, along with Linda Figg and Denny Pate being partners. So they clearly decided that the engineering will be limited to my knowledge, meaning Denny Pate, and whatever we have in office. And those guys are salaries. They're not the ones bidding on it, so why couldn't they leave them more time on this and get this right? Or maybe they didn't have the skill set. 20 plus professional engineers have all Googled over this for it during construction and etc. Plus an FIU Buildings College, right? Bridge, whatever. And nobody could figure out that forces might go down 10. I extrapolate that no way did they think forces were going down 10. That they extrapolate that the forces are going down 11. But here's the kicker of that. If you extrapolate forces are going down 11 and adding the compression in here, you also decided that whatever reinforcement that you have in here will deal with it, because there is no transverse cables inside this pocketed area, as we know now. The transverse cable starts out here. I don't know, the first one at 3 feet off of this thing somewhere. The first one, I've seen multiple answers now, 3 feet to 6 feet to 4 feet to 2 feet, based on where you're measuring from. So these forces applied here were just, in compression only. So they thought of this as just holding up, that there was no applied force they had to worry about transferring. That this is just a compressive force in here. While it sits here on the construction, while it sits here, it has no overhang effect. It's just a clamp force inside number 11, if you think of that. And they did number 2 also. So that's the extrapolation, and I'll share this with you, because remember, there's no transfer loads needed, because it must be fully supported here. I'm thinking it's fully supported there under the 12 all the way out to and including. I'm going to get to that for you guys in a minute. Including this blister, or you call it a nodule. This is part of the deck pour. So deck, this section, and this right to there was poured all as one. As I understand it by the OSHA report, this is poured. All the uprights were poured, and I'm calling diagonal and uprights interchangeably sometimes. So the upright and the diagonals were poured, then the canopy, and then the blister bar. So you have 1, 2, 3, 4 pours here. This is also on an angle on the outside of the deck with no post-tensioning running through it, but there's some type of bar in there. It has some type of hinging effect going on, awesomely so. It stayed intact. This bump out, you see here, this is the one that everybody have theorized blasted away. So let's go with the blast away. And you see here, this is a drain pipe, just plastic. We know in the failure you do not see anything on the ground. That we know that, and you look at the images beforehand, OSHA report, we're gonna identify that there is nothing to create. So to show you where I'm going with this, there is nothing, and there's the bar. It looks like these 2 bars would have been clamped on the 2 bars in the deck. These must have been extrapolated. It's a coupling that would have been screwed down, and apparently they didn't even screw down the coupling, and that would have been approximately there. So I'm trying to find an image. Hold on, I just had it. The image. Oh, right. Shoot. So this is the one right here at the pier. You see that? It's missing a chunk of hunk of love, hunk of burning love here. It's missing. How do you get a hunk of burning love missing right out of the center of the pier? That's what I said in the previous videos. You guys will see matchup. This is, to me, implicates that when the bridge was being pulled over and it took that bump, that's that part of 12 still intact. It's part of the deck, rather, that 12 sits on top of. It's still intact. At that point, it takes the bump. At that point, it gets the bump to rip it off and continue doing some redirect of the materials. It appears not to be on the ground, although I kept looking at this one chunk of one block that I keep wondering where that block came from. I don't think it's that. It's a block on top of sits on top of the deck. I don't want it. I don't think it's that. I think it's inside here. Reason why I don't think it's that because I can't picture that pipe surviving and leaving the remainder what's left as here. I don't have my dimensions. Possibly it is the lower half of that chunk you see on the deck, a big chunk of concrete we see on the deck that I have to count for. Perhaps it is the bottom of 12 right there, and then it rolled on top of the deck. Perhaps I can show you that in a moment, but it would be from down here. Now, let's go to the report, and I'll show you. Let me scroll up. So right there is where we take the bump. Right over here is where that bump is, and it pulls down the banner. Let's scroll to the end of this deal. It's very important, these damn braces and all that stuff. It's very important to establish, establish what went wrong here. What went wrong here is engineering. Engineering went wrong. It's so many things. Money, lack of proper supervision, overconfidence of everyone, what they thought they designed. When I say everyone, I mean F.2, I mean FIU, I mean CEI. Everybody having overconfidence instead of going, hey, this is the beginning of the end right here. How do we get in this deck? How do we get any movement? This needs to be addressed. This is on 2/28. You see, February 28th, way before then. This is an opening crack. This is and now it looks like it's going across there. We have one on 2, another day 2. So we've already got 2/28. This was doing the load testing. So apparently, if this is true, then we already have the dipping of the deck. I would love to know that load testing. Love to know, and I'd love to see the follow-up images with the pencil line through it to see the movement. If considering the pencil line was done with a straight edge. Let me chase to the bottom here. Now you don't see the cracking going around the base on this. I mean, put your damn hand in the photograph. Just take the photograph. I know why I did it though. 2/28. I do this stupid stuff myself. Take note of his hand. You see his hand like this in an arch shape? That's his damn measurement. He can look at that later on and scale it himself and going, 4 inches, take a photograph. Because no tape measure is present in his hand. He's just using his hand as a gap for measurement. Apparently trying to figure out center line or something. All right, let me jump to. So there's the part I'm saying took a bump, took a rotation right here. This part right here took the bump that we see in that image. That this possibly could be the block that we see sitting on the deck. As it bumped, the deck went down, it came down secondarily and landed on the deck. It's probably the only piece of solid material that I could address, that I could say that came from. I looked at the roof, etc. So this appears to be below 12. I'm hoping for more images to appear. I did do the FOIA request. That was to no avail. It's going to be to no avail until after the court case, as I understand. So, if I can share anything else, I sure will. here is that line. You see the line here? This is at the deck line. So you see how far we're down here? So here's the line. Here's the part that's right about there is what's right below the line. Okay, so of course, there's the line. This line is very important. And we go down here, what are the odds? Right about where that, whatever that is going on. So you look here, and there's the line. There's that section I mentioned. There's a little boxy box alongside. That boxy box is right out of view. Right out of view. The box. It's above this. Plain in the image. This is on March 15th. Oh, wait a minute. Investigation on March 15th. This is on March 12th. Oh, good data. Good data that we seem to miss this. The crack like hell I thought was all on the 10th, but this is actually the 12th. So 2 days later, because crack like hell I don't think does not show this. We're going to look at crack like hell again. But on BP, this is BPA then. Now I know how to determine BPA. See? BPA has this lying down. I think crack like hell has it. No, crack like hell has it there too. March 10th right here. So there's your crack like hell. So BPA, we've got a timeline of 2 days we're looking at here. We're missing it, guys. We're missing some good data here. So I got to get it back to crack like hell and compare BPA 312. That's a two-day progression. That looks pretty damn even Steven, doesn't it? That's already out. It appears to crack like hell. This is on 312, and 2 days later our status quo, which I sort of alluded to when I said what's holding this deck up is the number 11 having the post-tension rod still in it. It's now stopped this from falling all the way down to the pier, causing total, well, it should cause, it would be ultimate failure, I would guess. I'm theorizing at that point, right? I can't say it 100%, but I think that bar coming through 12, top number B, is holding this on. Holding this on. What else would be holding us on from falling off? What else would it be? There's got to be some clamp force holding this on. And I only have one clamp force, and that would be B. A is in the deck. So B is in the back of this little lady here. So B is holding on. Now you could say the canopy has some clamp force. I would say it has more of a torque force. Yeah, you know, I could argue that it has some ability to hold it. In fact, I'd change it the other way. I actually say the canopy's water responsibility giving me my downward and upward lift. Your release of the load lets you slide down. This is a deck failure, guys. This is a longitudinal deck failure. Just so you know, that's where it ultimately, it just keeps coming around and around to deck failure. All right, there is that part there, and right below it, here's our crack. C-R-A-K-E. C-R-A-K-E, crack. C-R-A-C-K. All right, I'm doing that for psychological reasons. It changes up the damn content, gets you make sure you stay awake. All right, there's this crack here, right? And there's this white. See different colors of materials? So we jump here again, just for clarity, to help you guys find this all on your own. There's this color, there's a different color of material. That's approximately where that crack is presented. Cracks are failures. Cracks are not accidental. Cracks are not acceptable unless they're just surface cracks. You know, who am I talking like now? Cracks are total failures, guys. This is not something you just glue back together. You have to find out why the crack happened. All right, so I'm being a little silly, but that's the way I present sometimes. That's because I have the confidence to be silly and present. So here we go. 1 day later, 3/13 over 312 about BPA. They removed the piece and they placed two pieces here, apparently. This appears to have a greater gap. We appear to be able to see down into the voids, but the angle of photography would change somewhat too. Why is this down there? Why is this down there? Somebody do some exploration. And what is this? But what is this? Let's go back to 312 and see if we, from that angle, do we have that on the deck? So there it is there. Let me see if I can triangulate it with the reinforcement. It's on this side of the reinforcement, apparently below, looking for symmetry, and I have symmetry, center line, so that's west, east, I don't know, north, south, west of the post, if this is the north end, so west, so per my determination of west, so it's over here still out of sight. Okay, so on 312, I can't see it, it's out of sight. I do not see the shim either. And here I don't see it on the ground. I see some flaked material here. And let's go to that one where he's above, this one here. So yeah, on 312, we don't have that material sitting down there. So I would love to go and photograph more. And then we got this material, whatever this may be, stacked up here, ready to go. Are these the shims they were supposed to be applying? Are these the shims? I would think, you know, I like that idea. These might be the shims right in front of us. And then right here is the, so they've already started a repair process. Maybe it's just tile and they're going to tile over it. I'm being facetious. So, yeah. And then here we are with this. So we got that broken off piece. Here's that gap now. This is what I said let's come back to. So here's the gap. Now let's just 312. Let's go to the next day. So 312, we've got this. On 313, we got repairs happening, don't we? Apparently, of some type. So we've got the pack of shims missing. What I call shims. Apparently this might be it here. And remember, I'm extrapolating, I'm reaching. We've got some, you know, removing of some concrete, some work going on here. And this piece is, where's it go? Where's this piece go? You can possibly puzzle it back to that piece up top there. Or are they working on the damn bridge? Are they pounding at it? Okay, so this was on 312. And now, I said I wish I had the timelines of this, but now we have the timeline. This photograph was taken, obviously, before this photograph. It's not there. He didn't pick it up holding his hand, place it back down, did he? Or she. So, kicked it around for what reason? To hear the shims again, apparently, and on this date, we've got something going on right here. This point they're taking measurements, though. Trying to what? What the points of measurements? If you don't know what the hell you're looking at, what's the point of taking a measurement? On 314, we got the third day now. 310, 312, and 310. We got BPA at 312, 313, and 314 now. And what's the point? So this is being held on, I think, at this point by the number A, and I don't think you're going to get any. It's not going to do anything besides rock a little bit, perhaps. Still trying to find its ultimate equilibrium. So if this is the edge of the deck, this appears to be. We're looking at a crack that happened in the deck, but yet we're looking at a material face. We're looking at, well, this is on an angle, so that's not fair, but off of this deck, if we slide over, this is a material face. This implies, again, an elevation took place also. Not only a break, but an elevation change. Now that's hinged upwards. This is not, you can see that this is on an angle, apparent on an angle. And this one also. That's why I had to pick something over here to make that statement. This is a hinge up also. This is on 313. That's a sliding, but not, you have it sliding this direction. I have it sliding from east to west, a lateral movement, not a longitudinal movement along the deck. It's some longitudinal as it takes a hinge effect and back up. You can pull by there. Let me jump off of this. Let me jump over to kind of wrapping it up for you a bit, and that's how I get a transverse movement, obviously, and we talked about in my other video. And there we go, and that's okay. So no reason to beat that one up, but I wanted to show you. We got to get to the end. Let me rotate clockwise. This hunk of, no, okay. Let me do that one more time. Well, that didn't work out. There we go. So this big hunk of love right here. This might be the bottom of 12. It's the only hunk of metal, of course I said metal. Only hunk of love I could find that works out. I mean, clearly, if this has ductwork ribbing inside of it, then we could put this inside the number 11 or 12. We just need to see the full look around this guy, give us a full view of it. And when I say the ribbing, so if you remember the one video I did where I talk about, clearly you can see these ribs will create an impression in the concrete when you pour around them. Now, after the fact, you get to actually see how, if they had honeycombs, etc. If this has any, right up here, if it has any honeycombs like that, around honeycombs, if it has any profile of the ribs inside of it, you can put this back in place. You know just where it went. Obviously, you're looking at the shims, and these two pieces of rebar I find very intriguing. Just broke free, and there you are. This beautiful piece of hunk of love might be the part that I'm pointing at right here, even though this is 4 feet. It seems like it's bigger than, that would be 2 feet. You guys got to scale that in your brain. Is that less than 2 feet? You've got to see where that works. And the coloration would tell us too. But that piece I've always liked to put back in there. And I would put that on the outside, not back in this hole. Not back in the hole, unless you can find that ribbing in there. So let's go to this end here. So that big hunk, I can't put it between all this and let it survive and then break free and land last on the deck. I could if I could see that it had the ribs on it, etc. You can go zoom in on these guys and get the numbers steel too. If you zoom in on these pictures, they've got some numbers on these steel. So I think this was possibly inside this part right here was inside of the 12 right here and going up, straddling left and right. And when this came off, it slid off the deck. It broke. That's where it took a bump. So we now know, or based on this says that part of the deck was still structurally intact. To do this much damage, it had to be fully structurally intact. I mean, not fully, but enough to rip through that and not take a bounce off. It held out. You have the trade-off of the materials. Obviously, that's a lot of concrete there, and the one that was doing the impacting had reinforcement in it, and it's tied to the deck area. So, just want to share that with you. Now, you can come in here also and do things like shadows if you want to try to explore something differently. So you bring up the shadows. Shadows would be in here. And when you do that, you then can start seeing the reinforcement. I just want to help you guys and do your own investigation if you want, even on the other forums. Mea culpa, if you will. There's the bar standing up, so we can see that it's there. But we have this piece to put back together. It's a nice piece. I mean, is that the bottom of the top part of the pipe? These photographically would tell the story of how this failure took place. But that's a nice piece. Does it go on the side here? Does it come off of 11? Where does it go? It does matter. It does matter. It tells the story of the failure of this nodal area that everybody's obsessed with. Me, I'm I'm pretty much got it nailed. I'm pretty much happy content with my evaluation. It has a couple of errors that need to be fixed, or flaws, if you will, that need to be resolved. That it has two or three people with this post tensioning. I don't have the as-built. We don't really know. It's extrapolation if they deviated from the as-built, except for we do know that at one point Erica did, and I think FDOT approved our deviation from transverse cabling. I don't know what that deviation was. Is it all in favor of making the structure stronger, or was it, what was it? We don't know. It just said that she's made changes, but they were ready to pour that night. Whatever the changes were, they was going to resolve it engineering wise, no matter what, by pouring that night. If we can verify that pour took place that night, we know that somebody agreed to Erica's deviation from the plans. There's that hinging right here, guys, of 12. So from here to here is the hinging. And obviously you can follow the rebar reinforcement, and where it turns, that's the hinging also. I'm going to terminate this video. It might be a little long. You guys can come over here and find it. I know I said I would pause this so you can get a screenshot. Let me do that. Let me clean this up a little bit. Let me move that over there. I think I can get rid of that. Right. This is in your screenshot, so you're going to be stuck with this. I'll try to make it larger for you. All right, I'll pause right there. I'll end there, and that way you can take your time grabbing your screenshot. Interesting, if all that torque that took place there, you see no brakes in here? Possibly right here. But that's how, this bridge really could have worked. It could have worked. They just missed a few details. And it might have lasted 6 to 12 years. I'm not a post-tension fan. I really love what it can do, but come on, let's go back to steel. It's predictable. This stuff is not predictable. And I didn't mean the word stuff. Did I want to share anything else? Looking at my tabs. Oh, yeah. So frequently I go over here and I refresh the page. You guys should do that too. FDOT Florida Transportation, they release and recycle the page. I'm getting tired of this. Hopefully, recycling the page. Hopefully something will pop up. The last update was then. And then also I go to the FOIA request that I have. I keep refreshing that from my email and from the public one to see if there's a difference. They align. If I go from my email and come into this, it comes right back to here. So if you guys go to this one, you'll see that it comes out to the same release. Remember, their facilities management, that's like their code enforcement. It's the same authority that FIU had given the BPA, CEI, same thing, as the facility management, which is the authority. I believe there's two, and it's FIU, of course. So FIU, this authority, and BPA, all having this authority that's equal. They made them an equal. If you can find that in the contract, they made, and you can find it here somewhere. They made BPA an equal. Hey, terminating video. I said I would end it with the, with the other one. Let's look. So here's that 10-inch sticking off there. Right about here is where your brake is, which is in the report as the crack. Anyway, think of this as a diaphragm girder system, not just a diaphragm, not this sliding action. Please, anyway, consider that. There's some reinforcement there that's been, we don't know if it's been cut or not by whomever. We don't know. Apparently they take some liberties like this. You guys know what I'm talking about when you show this, what I really mean. Take care.